Assalamu alaikum wa rahmatullahi wa barakatuh. يعطيكم العافية. Today we are going to answer October-November 2021 Physics Unit 1 Edexcel. Okay. In this paper, we don't have mark scheme yet for it, so we are going to answer it now, and we will see later when the results come out what's the mark scheme and what are the answers that we got it, if it's correct or not, inshallah. So we are going to skip, as usual, the multiple choice questions. Okay. And we start from question 11. Then at the end of the exam, we'll return back to question number 11. That's my first advice when you are going to do the exam, inshallah. Okay, so what they ask. Question number 11. A toy car is released from rest, okay, and rolls down a slope as shown. This is the mass of the car, and this is the speed on the bottom. So this is U is 0, and this is V, okay. Calculate the increase of the kinetic energy as it accelerates down. Now we know that the change or the increase of the kinetic energy, شكرا للشباب اللي عم بيبعتوا لي الانسرز اللي formulas exactly, equal the kinetic energy final minus what the kinetic energy initial, and the kinetic energy initial is 0. The kinetic energy final, it's half mv square. Why 0? Because it was at rest. So which will equal half multiplied by 0.16, the mass multiplied by 2.6 square. And the answer is, if anyone calculated, if you please give me the answer. And the answer, it will be in what? In joules. Give me the answer, 3 significant figures, if you please. I want from you to use your calculators to help me to save more time. Yes, exactly. شكرا يا حمزة. 0.4541 joules. Exactly. شكرا يا نور. Okay. That's part A. What they ask in part B. As the car accelerates down the slope, the work done against friction forces is this amount. This is the work done against friction forces. Calculate the vertical displacement of the car in the beginning, in the initial position here. Okay, in the beginning. So what do we have here? We know that gravitational potential energy initial plus kinetic energy initial, which is 0, plus work done by engine, if there is work, no, there is no work, equal, that's the total energy before, equal gravitational potential energy final, okay, which is 0 because it reached the ground level, plus the kinetic energy final that we just find it out, okay, 0.541 plus the work done by what? By friction forces or air resistance or whatever, okay, which is how much they give it to you, 0.26. Now the gravitational potential energy, as we know, it's mgh initial. They ask about the mass initially, okay. They ask about the initial height. Sorry, they ask about the initial height. So the initial height, it's equal the addition of these two values. Use your calculator, if you please. Okay, divided by what? Divided by the mass and the gravity acceleration, which is 0.16 multiplied by 9.81. And how much is the height? It will be can you please give me your answer by using calculator to 2 or 3 significant figures? And the answer, it will be 19.11 meter. Are you sure? I'm sorry. Okay, so the answer is 0.51 meters. شكرا يا نور, شكرا يا حمزة. Okay. تمام? No problem. طيب. I want from the rest of you to use their calculators. Now, if you please, you can take a screenshot for the answer here for these two parts. And don't forget this formula, okay, during the exam. It's very useful to understand it and to use it, okay, that the total energy before equal the total energy what? After. Don't forget this formula. Any question for this part here? Question number 11. Anything? Okay, let's move on. Can you slow down a bit so we can write? Yes, the idea that we have, yes, I'll try, but we have 2 hours to explain all details here. This is an easy question so far, but no problem. I'll try. Okay. Now let's move on to question 12. In question 12, it's obvious that talks about momentum because there is collisions. Let's see what they say. An aluminum sphere collide head-on collision with a stationary, that means the initial speed is 0, steel sphere. The two spheres are moved off separately after collision. So there was two objects and remains two objects. Say the principle of conservation of momentum. What are the keywords about the conservation of momentum? Yes, total collision before equal total collision after enclosed system, isolated system. Bravo. شكرا يا نور, شكرا يا شهد, شكرا يا حمزة. Huh? So what we are going to say, in isolated system that has no external force, no external forces, the total momentum before any collision is equal the total momentum after the collision. The total momentum after the collision. Okay. Now, why I write it in this way? So if there is more details or there's more ideas on mark scheme, I can get everything later on. Next, part B. What they said. The aluminum sphere has an initial velocity of 10 meters per second. So we have aluminum, we have steel, and we are going to write their masses, their initial speed, and their final speed. Okay. So the mass here, it's given 2.7, and the initial speed is 10. Move to a stationary steel ball that has a mass of 7.9. Immediately after collision, the velocity of the steel ball is 5. Okay. Now calculate the velocity v of the aluminum sphere after the collision. They ask about this velocity here. They ask about this velocity, how we can find it out. Now, what's the formula for this? We know that the formula is that we just write it down, that the total momentum before equal the total momentum after. Thank you, Hamza. So the momentum of aluminum initially plus the momentum of the steel initially, okay, equal the momentum of aluminum finally plus the momentum for steel finally, and the formula will be in this way. I can write it down. Okay, it will be M. Let me change the color. It will be M aluminum U aluminum. That's the initial momentum for aluminum equal M steel initial speed for steel equal M aluminum V aluminum. That's what they ask about it, plus M for the steel times velocity of of the steel. So in this situation here, we will substitute the values that we have it in the table. Okay, so 2.7 multiplied by 10 plus 0, because the initial speed is 0, equal 2.7 V plus 7.9 times 5. By using the calculator, our answer will be -4. Give me the answer if you please. -4.62 meters per second. Thank you. Now, if you didn't put the negative sign, it doesn't matter, because here this negative sign represents what? Thank you. Hamza fixed the answer. Okay, to be like this. Okay. So what this negative means? The negative sign means what? Means opposite what? Opposite direction. That means it bounces. Okay, opposite direction. Okay, but they didn't ask about it, so we could keep the negative sign here like this. Okay, tamam. Any question here? Any question here? Let's repeat that. So the total momentum before collision equal the total momentum after collision. We find the momentum for both balls or spheres before. then it's equal the total momentum after, according to the long formula that we know it here. Okay, and we substitute the values and we get the correct answer, inshallah. And the negative here means the opposite direction. They ask about the velocity. That's why I'm supposed to keep the negative sign. Okay. Now let's move on. Question 13. A sledge accelerates due to gravity. Okay, from rest, that means the initial speed is 0. Down a frictionless slope. That means when it starts from rest, that means the friction force and the air resistance will be small. Then as the speed increases, the air resistance increases. Air resistance can be ignored, no problem, okay? The slope at an angle of 6.9 degrees to the horizontal, and they said it's accelerate. That means the force downward the slope is greater than opposing the slope. That means the friction is less. Okay, complete the free body diagram, the force of the diagram as shown here. So what do we have? We have three forces, as you know. What are these three forces? Yes, send it to me. What are these three forces? Yalla ya shabab. Yes, thank you. They are the friction, the normal contact force, and the weight. Bravo. So we'll draw the weight, which is the greatest one, the longest one, and the biggest one. I will draw it with an arrow, which is bigger. And the normal contact in this direction, okay, the normal reaction. And I will put a small arrow represent what? The friction in the opposite direction, because they are not balanced. So this is the friction. And if I want to label an angle, okay, if I want to label an angle, the angle 6.9, it will be here. This angle, which will be 6.9 degrees. Okay, if they ask me to label it, and I usually draw it without asking me. Okay. Okay. They said frictionless. I'm sorry, friction. Frictionless. I'm sorry. I thought that there is friction. I read it in the opposite. Thank you. There's no friction. Okay. I'm sorry. Okay. That's better, actually. The slope has a total length of 60 meters. This is the distance. Show that the initial acceleration of the sledge on the slope is approximately 1 meter per second squared. This value, we are going to use it in the next part, double I. So who can tell me, how can we find the initial acceleration? By which formula? Thank you, Hamza. What is the formula that I'm going to use it? Exactly. Thank you, Shahid. Another one. What's the formula that I'm going to use it? Now we know that we have these two forces in the opposite direction and cancel out each other, and there is a force that makes the acceleration. This is the normal reaction force, and this is the weight perpendicular to the surface, and this is the weight parallel to the surface. And the weight parallel to the surface, it makes the acceleration. So resultant force equal mass multiplied by the acceleration. The resultant force, it's the weight parallel, and we know that it's equal mg what? Sine theta. This is equal the mass multiplied by the acceleration. So m with m cancel out each other. The mass with the mass cancel out each other, and theta is 6.9. So the acceleration by using calculator equal g sine 6.9. Okay, or you can write instead of acceleration or g, you can write directly acceleration equal 9.81 multiplied by this, which is equal to 1.2 meters per second square. Yes, 1.17, that means 1.2, two significant figures. Thank you, Hamza. Next, what they said. They said that determine the speed at the edge of the slope. Okay, now we know that we have to use SOVAT here because we have acceleration. Now I don't have time, and the distance is 60. Okay, and the initial speed is 0, and the final speed, I don't have it. Okay, they ask about it, and the acceleration that we just find it out, it's 1.2. So which formula will you use? Exactly. Tell me. شكرا يا حمزة. Which formula will you use? يلا ابعتوا لي equations. Write it down. What is the equation that I'm going to use it? Exactly. شكرا. It's v square equal u square plus 2as. شكرا يا نور. Okay, so we know that V that they ask about it, it's equal the square root of 0 square, which is 0, plus 2 times 1.2 multiplied by what? The distance, which is 60 meters. And by using calculator, how much is the answer? Yes, how much is the answer by using the calculator? And don't forget the unit, it's meter per what? Per second. What's the answer? يلا ابعتوا لي الانسر بالcalculators. Is it 12? Okay. 12. شكرا يا نور, شكرا يا حمزة. 12 meters per what? Per second. Two significant figures. شكرا. طيب, where's the rest of you? ليش الباقي ما عم بيجاوب؟ أمير, هنا, رباح, شهد. في ناس طلعوا من الجروب. في ناس طلعوا كانوا موجودين طلعوا. طيب يلا, let's continue. Now what they ask here, determine the time taken for the sledge to travel at the end of the slope. Now we have the same thing, but they ask about the time, and I don't have V. Let's assume that I don't have V. In this situation that I don't have V, and they ask about the time, yes, I will use the formula. Yes, Rahali. No. There is acceleration. It's never be used speed equal distance over time. There is acceleration. I will never use this equation because there is acceleration. So the distance or the displacement equal ut plus half a t squared. So the displacement, which is 60, equals 0 plus half multiplied by the acceleration that they give it to us, or we just find it out, 1.2, sorry, we find it out, multiplied by the time square, and we will need to find the time, and the time it will be what? By using calculator, it will be 10 seconds. So t equal square root of 2 times 60 divided by 1.2. Yes, two significant figures, it's 10 seconds. شكرا يا حمزة. شكرا يا شهد. شكرا يا نور. So we will use the same so that, okay, but I don't have V in this situation. I have time because I'll ask about the time at the end of the 60 meters. Next, question 40. A student carried out an experiment to determine the Young modulus of a sample of steel, okay, stainless steel in a form of a wire, okay? The student add weight to the wire and measure the corresponding what? Extension, okay? The wire has an unstretched length. This is the original length of 2.6 meters and a diameter. Now this diameter, I will find the radius from it. Then I will find the area of it because I will find the Young modulus, okay? So I have to divide this value by 2, then by finding the area. Okay, the student plot a graph of the weight against extension. The weight means force against extension. The graph shows the limit of proportionality not exceeded. So it's a straight line, do not exceed the limit of proportionality. State what is meant by limit of proportionality. Now, some of you send me answers. What are the keywords for limit of proportionality? شكرا يا حمزة for your answer. I will read it later. Okay, okay, thank you يا حمزة. Your answer is correct. برافو يا شهد. شكرا. اوكي شكرا يا نور. مين كمان باعت أجوبة؟ شكرا يا رباح. برافو صح. Okay. So we need to make our answer 3 marks. If it's only 1 mark, but we have to write it as 3 marks. Is the maximum force at which the extension is directly proportional to the force acts on it and still obeys Hooke's law. يا عيني عليكم. يا سلام عليكم. شكرا. أجوبة رائعة من أشخاص رائعين. You are amazing. Thank you. So we have the original length here. Okay, we have the diameter that we have to put it as radius to find the area, okay, which is pi r squared, don't forget that, okay. So the graph shows, okay, the student, okay, here the student's graph are shown below, weight with extension, don't forget here it's times 10 to the power of -10. Determine the gradient. The gradient, we know that it's k because it's the weight over what? Over the extension, force over what? Over E or extension, okay, or X, whatever. So let's take a point which is far here, and I will use my ruler to show them that I take this point. Okay, how much is the coordination of this point? Okay, it's on the straight line. Whenever the point is farther, I'll be more accurate. As you can see, it's 35, 36, 37. So 37 minus 0 divided by 2 minus 0 between brackets times 10 to the power of -3. By using the calculator, it will be 1.86 times 10 to the power of 4. What's the unit here? What is the unit? 1 point, exactly. It's Newton per meter. I'm dividing the weight by the extension, Newton per what? Meter. شكرا يا شهد, شكرا يا حمزة, شكرا يا رباح. Teacher, what do we do when the axis is a switch? They ask about the gradient, no problem. They ask about the gradient. So we find the gradient. If they ask about the stiffness and we switch the axis, we'll switch. We find the gradient, then we inverse the answer, 1 over the gradient. Okay, it depends on the question. Because they ask about the gradient, don't worry. Okay, don't forget that this gradient, I will use it for the next part. Look what they ask. Determine the Young modulus. Why? Because the question in the beginning, they ask about the Young modulus. And we have to know about Young modulus here. Okay, so let's switch the color. Now this value, okay, that we just find, it's force over extension. Don't forget that. And Young modulus, as we know, Young modulus equal stress over strain, which is equal Phi. Now, force over extension, I just find it out, which is 1.86 times 10 to the power of -4 or +4, -4. Okay, multiply by what? The length. How much was the original length? It was 2.6. Are you sure, Hamza, this is the answer, -4? I'm not sure it's -4. It's supposed to be +4. Check if you please. Check if you please your answer. Is 37 divided by 2? Yes, it is positive. Allah يسعدك يا رب. Okay. Shukran, shukran. So, no problem. So, +4, let me return back to the green color. So, +4 or not necessarily right, positive or negative. Okay. Multiply by the length, which is 2.6, divided by what? Divided by the cross-section area, which is what? What's the cross-section area? It's pi, the radius, which is this value, the diameter, 5.6 times 10 to the power of -4. 5.6 times 10 to the power of -4 divided by 2. And all of this, I will what? I'll square it. Use your calculator. If you please give me the correct answer, لو سمحتوا. So that's how we can find Young modulus. You can write it FL over XA, or doesn't matter, this one or this formula. The idea that in the previous part, we find K, which is what? Which is F over X or F over E. That was our what? Our gradient, our K. Yalla, what's the answer here? Yalla, give me the answer if you please. I'm waiting for you. 1.96 times 10 to the power of 11. What's the unit? What's the unit for Young modulus? What's the unit? شكرا يا رحال. The other, the rest of you, what's the unit? Not Pascal dot second. Pascal dot second is the coefficient of viscosity. Oh, yes, it is Pascal. شكرا يا شهد. Yes. يسلموا ايديكم. يسلموا. تمام، شكرا يا نور. رائع، برافو. Okay. That's the Young modulus for stainless steel. The breaking stress for this stainless steel is known to be how much? 480 megapascal. Deduce whether safe for the student to increase the weight to how much? To 100? Let's do that. Let's find out. So what do we have here? We have the formula for stress equal force over what? Area. So we'll find, is the stress by increasing the force by 100, it will be more or less than this point. If it's more, that means it's not safety. If it's less, it means safety. So the force, which is 100, divided by the area, which is this one, pi 5.6 times 10 to the power of -4 divided by 2 all square. If you please use your calculator to give me the answer. And the answer is what? شكرا يا حمزة. Give me the final answer. It's force over area. Force over area, not Young modulus over area. Give me the final answer for this one, لو سمحتوا. Yes, it's 4.06 times 10 to the power of 7. That means 40.6 times 10 to the power of 6. That means 40.6 megapascal, which is less than how much? Yes. Which is less than how much? 480 megapascal. So yes, it is safe. Yes, it is safe. تمام. Check if you please your answer لأنه في ناس عم بيبعتوا لي أجوبة غلط. في ناس عم بيبعتوا لي أرقام تانية. Teacher, the question above, don't we divide or not multiply? Again, now we know that stress equal force over area, right? We find the area and they give us the force, which is 100. So 100 divided by area, we'll find how much it is, the stress. In part B, where here, stress over strain, that goes to be flee, and force over extension, we just find it out in the previous part, this one, 1.86 times 10 to the power of 4, we put it here, multiply by the length, divided by the area, and we get this answer. Okay, Rabah? Is it clear? Teacher, the answer is, that means to the power of how many zeros here do we have? في ناس عم بيحكوا لي here the power of 8. I need to check your answer. Please double check. Is it the power of 8 or the power of 7? The answer. Okay, شكرا يا نور. تمام. It's to the power of 8. That means it will be 406 megapascal. شكرا يا شهد. شكرا يا نور. شكرا يا رباح. يا حمزة كمان. برافو عليك يا أمير. مرة ثانية check your calculator. Okay, you did correctly, but you give me the wrong answer. So it is safe, not same, safe. It is safe. Okay. تمام. So far صار تقريبا يا شباب نص ساعة حلينا تقريبا 4 أسئلة. That's good. That's good. يعني we are too fast. الحمد لله. يعني we can use the save time to the questions like this one. Okay, to the rest of the question like this one. Question 15. The photograph shows a toy car that contains a spring. Pulling the car backward along the floor, compressing the spring. Energy is stored by compressing the spring. What is this energy called? Elastic potential energy. So we do a work on this car when we move it backwards to store energy, and this energy we will use it to do work against what? The car to move forwards, as we are going to see now. The car is released and the spring return back to original size. Okay, there is a forward force on the car from the floor, and the car moves forward. Okay. Yes, from the floor. Thank you. في ناس عم بيبعتوا لي شو لازم نكتب. Okay. Explain why the force exerts a forward force on the car. That's the first question. And how this force affects the motion of the car as the spring return back to original what state. That's the second question. في ناس بلشوا يبعتوا لي كثير اجوا صار. خلينا افتحهم اقراهم هيك in details كل واحد لحال. اوكي بس بعد اذنكم. اوكي شو الاجوبه اللي كاتبه مكتوبات؟ في ناس كاتبين the car's wheel exerts a backward force on the floor due to the spring store energy. برافو يا عبد الفتاح. Okay, and so due to the third law, the car pushes forward. The car. Bravo. That's Newton. Thank you, Shahad. That we use Newton's what third law. But what about the Newton's second law? Is this the only force horizontally act? So that makes it accelerate forward to move forward. So we have to mention about also what Newton, what second law. What else? Who can give me other answers? But what about the energy stored? Can we say that this will make a work, and this work do a force along the distance where the spring is returned back to its original shape? So all these ideas we have to mention it. If I want to write together, me and you, the mark scheme, I have to mention that elastic energy do energy طبعا elastic energy do a work, وهذا الwork عبارة عن force okay multiply by distance, وهاي distance until the spring return back. Okay, returns. Okay, بنقدر نحكي إنه الwheels okay pushes the floor okay backward, and a Newton third law of motion نحكي الفلور make the reaction equal and opposite reaction. تمام برافو. and this force برافو عليكم, and هاي الفورس is the resultant force, and due to Newton's second law of motion, there is what يا شباب? There is acceleration. Bravo. There is acceleration. طب is this acceleration constant or changeable? Yes, bravo. So this acceleration is what is not constant, changeable, and also this energy, some of it is wasted. Exactly, some of the energy is dissipated into heat. Yes, into heat due to friction, or into sound, into heat due to friction. Teacher, I wrote my answer. خليني أكتب. You can send it to me on كثير جواب. Initially, the car has elastic potential energy stored when the spring of the car compressed, and also the spring was applied a pushing force on the floor. Okay, when the spring was decompressed. Okay, when the car is released, the spring make a force on the ground by the wheels. This is action reaction. Okay, and the energy transfer into kinetic energy. Bravo عليك. I forget. No problem. Your answer is amazing. Tamam. You can write work, or you can say it's transfer into what? Into kinetic energy. But The word work is better because I'm talking about forces here. I need to use this force to explain what I'm going to say here. Excellent. You are a good team now. Yeah, our mark scheme is supposed to be by this statement, and we have to link these statements to each other. Excellent. Excellent. شايفين كيف؟ شايفين كيف? And we did this question in 6 minutes. We did this question in 6 or 7 minutes. Bravo. Let's move on. Question 16 about projectile. خلينا نرجع بالله عشان اللي بده ياخذ سكرين شوت. Okay, ياخذ سكرين شوت here. Okay, I'll write the informations. تمام. Let's move on to question 16. An explosion projects a rock into the air with a speed of how much? Can you send the answer you read a while ago on the group? Can you send the answer you read a while on the group? Okay, no problem. ماشي ما في مشكلة. An explosion projects a rock into the air with a speed of 50 meters per second at an angle to the horizontal of 40 degrees. So we have an initial speed, okay, with an angle of 40 degrees, and this initial speed has both the horizontal and vertical speeds, okay, vertical component, that's Vx, and this is U what Uy, okay. What they ask, show that the rock would reach a maximum height, okay, about 3 seconds after explosion. What we're going to do here, because they ask about maximum height, I'll think horizontally or vertically. Yes. Vertically, I will use so that, exactly. So first step, okay, I have to find the initial speed in the y-axis, which is u sine what? Theta, which is 50 sine what? 40. And how much is the answer? Give it to me. Then second step, I will think about what? So that. They ask about the time, and vertically, I know that the acceleration is negative 9.81, and at maximum height, the speed, it will be 0. This is the speed that I just find it out. Thank you, Amir. It's 32.1. I'll put it here, 32.1. Which formula that doesn't have S, I will use it to find the time. I will use the equation for acceleration. Okay, acceleration equal V minus U over T, or you can say V equal U plus AT. شكرا يا رحال, شكرا يا أمير, شكرا للجميع. برافو عليك, والله ما شاء الله عليك, a good team. 0 equal 32.1, okay, minus 9.81 multiplied by T. So T equal 32.1 divided by 9.81, which is approximately how much? 3.3 seconds, which is approximately 3 seconds. We will use this value to answer part B for sure. شكرا يا أمير, شكرا يا حمزة. Write this down. So 2 steps to answer this question. This is step number 1, to find how much the initial vertical speed, and step number 2, we'll write so that, and we will use the equation that doesn't have S to find the time, which is V equal U plus 80. Next, part B. The rock moves in the direction of a hill. Okay, we have a hill, and the angle of it it's 20 degrees to the horizontal. The hill is 20 degrees above what? The horizontal as shown. After a certain distance, okay, the rock will land on the side of the hill. Of course, after a certain distance, we don't know if it reached the maximum height or not. It will land on what? The side of the hill, okay? Type what they ask. Deduce whether the rock hits the ground before reaching the maximum height, okay, or after. Of course, air resistance is negligible, and this 6 mark questions. طيب يا شباب, كيف بدنا نجاوب هذا السؤال؟ هلا احنا اعطانا information كثير مهمه اللي هي الايش؟ الفlying time to reach the maximum height اللي هو قد 3.3. I will use it to find what? The maximum height. Exactly. طيب خلينا نشوف. So S, okay, equal, we can use any equation. So that S is unknown, U it's 32.1, V it's 0, negative 9.81, and the time is 3.3. Okay, if you want to use it, if you don't use it, no problem. So we are going to use V square equal U square plus 2AS. Okay, to know how much is the maximum height. There are several ways to answer this question. شكرا يا شاهد وشكرا يا أمير. Okay. هلا أمير بحكي suggest إنه ليش ما نعمل range? Why we don't find the range to reach the maximum height? Bravo. هلا I'm going to answer it in two different ways. شاهد, we have the time to find the maximum height. Yes. Okay, so we can use the equation. Okay, زي ما حكى حمزة, any equation to find the maximum height. So 0 equal 32.1 square minus 2 times 9.81. Why minus? Because the expression is negative. Multiply by S, and this S is the height. يلا أعطوني قد الجواب. Give me the answer. How much is the height? Which is 32.1 square over 2 times 9.81. How much is the height? يلا. It's 52.5 meters. Now, this is the maximum height for the rock with the explosion as shown. Now, if we need to see that how much is the height like this with an angle of 20 degrees. Now, the range here, I will use it as Amir said. Okay, and I have to know how much is the speed in the x-axis. Shukran. In the x-axis, how much is the speed, and I will multiply it by the time, okay, to find how much is the range. Then I will see how much is the height, and I will compare this height by this height that I will find it out. Yes, shukran, bravo. So first thing, I have to find how much is Vx, and we know it's U cosine theta, and it was 50 cosine 40 degrees, and the answer is how much? How much is 50 cosine 40? I need you to use their calculator faster لو سمحتوا عشان الأرقام بتهمنا هلا. فبطلع 38.3 yes meters per second. I will use this value to find what? The horizontal range. So the range in the x-axis equal the speed in the x-axis multiplied by the time, and 38.3 multiplied by 3.3 times 3.3, and the answer will be approximately 126 meters. Okay, three significant figures. Type. Now, let's see. Now, the whole range here, it's 126. I will find the height by using tan now, this fourth step. So, tan theta equal the height over the range in the x-axis. We'll do cross multiplication. So, height equal range multiplied by tan theta, which is equal to 126 tan 20 times tan 20, and the answer will be how much? 46 meter. Is 46 meter below or above the 52.5 meter? Yes, shukran, it is below. Can we use the time to determine whether the rock lands on the side of the hill? You can do that. That's another way to answer the question. Yes. So, and since the height 46 meter is less than the maximum height 52.5 meter. So it didn't land. It reaches the maximum height. It reaches the maximum height before landing. The maximum height before landing. That's one way to answer the question. There's other ways. Can you please go over the question again? Yes, I will do it in another way if you want, but not now, later عشان timing. هلا خلينا نشوف شو اللي صار. They ask about projectile motion, and they said that we have a side of a hill, okay? Like yesterday question, we have a flat surface. Now here we have a height hill, not a flat surface. So they will say that during the same time, okay, the 3.3 seconds, okay, 3.3 seconds, okay, how much is the range that it will move here horizontally? If we know the horizontal range and we know the angle here, we can find how much is the height of the hill, okay, like this, by using what? Tan theta equal the opposite, which is the height over what? The range that we find it, which is a speed in x-axis, multiplied by what? Multiplied by time. Okay, the time is 3.3 seconds. Now we use this time, 3.3 seconds, also to measure what? To measure the maximum height, the what? The rock reaches. For example, here the rock was the maximum height. And this maximum height, S, that we just find it out by using SOVAT, it was what? 52.5 meter, which is above or greater than the height that we find it here, which was how much? How much was it? 46 meter. 46 meter. So when the rock reached the maximum height, the height was the vertical height was 52.5 meter, which is greater than the height of the hill, okay, during the same time that covered by this rock, which is, okay, how much? 46 what? Meters. So that means it reached the maximum height without landing on what? On the ground or on the hill. Good. So what we did here, first step, we find the maximum height. That's it. This is the maximum height by the rock reached. Then we use to know how much the horizontal range travel, okay? And the horizontal range travel, we need to find the speed. Then we multiply it by 3.3 to find how much is the horizontal range. This is the horizontal distance. Okay. Then what we did here, we used tan theta to compare, to know how much to the hill, okay? For the hill, how much the what? How much was the height when the range was 126 meters? And by doing cross multiplication, it was only 46 meters with an angle of how much? 20 degrees. And the value of that, we just find it out here, the maximum height was less than the height of the hill, okay, by using this distance and the time, okay, for the range and for the flying time, 3.3 for the rock. Tamam. Take a screenshot if you please. Let's move on to question 17. Question 17. Water is dropped into a container of oil. Water is denser than oil, so it falls where? Down. Water is dropped into a container of oil. The water forms a small spherical drops that moves slowly downwards. A droplet moves downward with a constant what? Speed. The flow of the oil around the droplet was laminar. State what is meant by laminar flow. Yes, shukran Amir. What's meant by laminar flow? في ناس بعتوا لي هي أمير وهي حمزة. It is when the flow lines, okay, are parallel to each other. They are moved with a constant velocity. The movement through parallel layers with a constant speed without mixing. Okay, undisturbance layers. Okay, they are parallel. شكرا يا عبد الفتاح. برافو عليك. خلينا نكتب هلا. شو لازم نحكي؟ هلا أنا بحبش كلمة lie أوكي لأنهم هم layers أوكي that's number one. Number two, it's the movement or the flow of what? Exactly the movement of the fluid, exactly the movement of the fluid in parallel layers at steady speed or velocities without what? Without mixing. I think that we get the mark. Okay. شكرا يا أمير، شكرا يا عبد الفتاح، شكرا يا حمزة. Next. State the condition necessarily for the speed of the droplet to be constant. Excellent. حمزة شكرا. ها مين كمان يبعث لي جواب؟ I will not read Hamza's answer هلا. I'll read it later. It has to be small, I know, but not in this situation. It has to be spherical. Yes, these are Stokes law. Okay, it has to be laminar. That's Stokes law. It has to be low mass. That's for Stokes law. Be careful. What are the conditions for the speed to be constant? شكرا يا حمزة. حمزة الوحيد اللي جاوب لي الجواب الصح. الباقي جواب غلط. أيوة يا أمير. صح. شكرا يا حمزة. شكرا يا أمير. The resultant force equal how much? The resultant force must equal 0. Must be 0. شكرا يا حمزة وشكرا يا أمير. طيب. The other conditions that you mentioned is correct for Stokes law. These are the conditions and they tell us it's a slowly and it's a small. ماشي. They are okay. The resultant force must be 0 and the sphere must be move slowly and must be a small spherical shape. That for Stokes law to be used for what? Drag force, and to make and that's happened when the speed is constant and the thermal velocity when it's moving at thermal velocity there is no resultant force. So the condition here, it's no resultant force. In my opinion, that's the answer. I don't know the mark scheme if they accept your answers. We will see after a few weeks. Right. Part B. A spherical droplet has a volume. This is the volume. Calculate the weight of the droplet. The density of water is this small. So we know that density equal mass over volume, and they ask about the weight. So the weight, which is equal mass times gravity acceleration. So I will multiply the density of the water, multiply by the volume of the water droplet, multiply by G, and the answer will be 1000, 1 times 10 to the power of 3, multiply by the volume, 3.35 times 10 to the power of negative 8, multiply by gravity acceleration 9.81, and by using calculator, how much is the answer? We can rearrange the formula. Yes, of course, we can do that. Is this the upthrust? Yes, but the upthrust density of the fluid, the oil. Now here we are talking about density of the water. Okay, so it will be 3.35 times 10,000. How much is the answer? It's exactly 32.9 times 10 to the power of negative 5, or let's say 3.29 times 10 to the power of negative 4. That's better. Negative 4. What's the unit? In Newton. This is the weight of the droplet. So 3.29 times 10 to the power of negative 4 in Newton. Next, show that means we are going to use this value here, okay? Show that the upthrust on the weight droplet, okay, when it's completely submerged in water is approximately 3 times 10 to the power of -4 in Newton. The density of oil, now in this situation, Amir, we are going to say that density of the fluid, okay, multiplied by gravity acceleration, multiplied by the volume displaced, which is completely submerged, that means the volume. Okay, so we write 0.94 times 10 to the power of 3 multiplied by 9.81 multiplied by the volume, which is 3.35 times 10 to the power of -8. And by using calculator, the answer is how much? يلا مين مع آلة حاسبة؟ أعطيني الأنسر. It's 3.0 times 10 to the power of, yes. Yes, شكرا يا رحال، شكرا يا شهد، برافو عليكي. 3.09 times 10 to the power of what? -4 in Newton. 9. That means 9. Okay, 3.089. That means 3.09. Okay, 3 significant figure. Okay. So next, calculate the terminal velocity of this water drop when ash and the oil. The viscosity of the oil, they give it to us 0.11 Pascal per second. Now, since the water drop is falling down, that's the weight. What are the forces act on it in opposite direction? It's the drag force plus what? The upthrust. Exactly. So in this situation, we have to use Stokes' law. Exactly. So drag plus the upthrust is equal to what? To the weight. And the drag, we know it, which is 6 pi r eta v. They ask about v, the terminal velocity, equal the weight that we just find it out here. Okay, let's write weight minus upthrust. So v equal the weight, which is 3.29 times 10 to the power of -4 minus the upthrust, that which is 3.09 times 10 to the power of -4 divided by 6. Yes, they get. I thought they always give us that formula. Yes, they give us the formula for the drag, but not necessarily drag plus upthrust equal weight, because it depends on the situation, moving up, moving down, at rest. Okay, sometimes negligible the weight, some other times negligible the drag. Okay, 6 pi, the radius. Where is the radius? They didn't give us the radius. We have to find it out. We have to find it out from where? From the volume here. Okay. That's why it's 4 marks question. So the radius, we know that volume equal 4, thank you Hamza, 4/3 pi r cube. So that leads us that radius equal cubic root of the volume, which is, how much was the volume? 3.35 times 10 to the power of -8 divided by 4/3 pi. Okay, and we will use this value here to find the radius, multiply by eta, and the eta they give it to us, which is 0.11. How much is the radius here? If you have a calculator, can you give me the answer? How much here? Cubic root. Where's the cubic root here? Yes. Are you sure? Yes, shukran ya Hamza. 2 times 10 to the power of -3. By using the whole answer, how much is the terminal velocity? By using the whole thing here, that's why it has 4 marks. How much is the terminal velocity? Yes, how much is the terminal velocity? Give me the answer. 3.29 times 10 to the power of -4 meters per second. شكرا شكرا. هذا السؤال حلو، شو رايك يا مبيضين؟ صح؟ حلو صح؟ You will not neglect هاي العلامات كلياتها. It's only calculations, use the formula. Look here to the whole question from beginning, 2 marks on definitions, one mark on definition, 1 mark on the condition, resultant force equals 0, and 3 marks. Okay, this exam is not too hard. We will see the results and the mark, the grade boundaries, I don't know. 3 marks and 2 marks here and 4 marks here. Okay, let's move on to question 18. Now this question is hard. Let's see. Usually the last question is the hardest. Okay, is it the last question? No, it's not the last question. في كمان question 19. طيب يلا. Maybe it's long exam. خلينا نشوف. طيب خلينا بس للشباب والصبايا اللي حابين يعملوا سكرين شوت للانسر هير. اوكي تمام. يس تفضلي شهد. انت مش لحالك على فكره طلبت، في كثير ناس طلبوا. اوكي. Question 18. The diagram shows a system, okay, used to move a stone block up a ramp, like when they build pyramids. That was one of the theories, and that wasn't correct. It's written in the Quran from 1,400 years ago. It's not like this. They put molten sand in the place that they put it on the pyramids, and they use wood to fix it, its position. The block on the rope, a team of people used a rope to pull the block at a constant speed. This is a very unique word here, constant speed. That means the resultant force equals 0. Huh? Be careful. Okay, that means forces of pulling equal other forces downwards. Okay, type friction and the component of the weight downwards. Height of the ramp is 4.35 meter. Angle of the ramp 6 degrees. Okay, mass of the block 1 times 10^3. Speed of the block, they give us the slow speed, which is constant. Okay, total power, total average power, 6.25 kilowatt. Show that the total force that the team, okay, exert on the block is about 14 kilonewton. That means I will use this value for next parts. في ناس بلشوا يبعثوا لي أجوبة إنه since they are talking about the total power, let's say that it's instantaneous power and we have the speed, so we will say that power equal. طيب خلينا نشوف. Let's do this method يا حمزة. Okay, power equal force multiplied by what? Velocity. So that means force equal power, which is 6,250 divided by the velocity, which is what? 0.45. Is this the answer close to our answer? Yeah, where is your calculator? So 6,250 divided by 0.45, which is, yes, exactly. It's 13,890 watt in Newton. That means 13,900 in Newton. Now, one asked me, Ustad, why you didn't use a sine 6 degrees? The force, it's a parallel in the direction of the ramp. I will not use sine any angle. Okay, it's force multiplied by what? Velocity. This is the short way to answer the question, the smart way. There's a long way to answer the question, and I will get the same answer. Okay, it will be a disaster to do that. What I will do, I'll find the component of the weight sine theta, and I will try to find out how much the friction. I don't know it, and since it moved upwards, that means work equal force multiplied by distance. I have to know how far it's moved by the ramp. If I know, it's a long question. That's not the power or the force that the people they did it. Okay, the actual force something else. That's why they ask you show that, because I'm going to use this value to do what? To do the next part. Next part, what they ask here. Look here. Determine the total work done by the team. Now we know that work equal the force that we just find it out multiplied by the length or the distance of the ramp that I what we did it here. And how long it will be the ramp if the height is 4 point, okay, if the height is 4.35, okay, how long it will be the hypotenuse of the ramp if this angle is 60 degrees. This is the distance that I needed. I will use sine, yes, exactly. So when I said sine 6 equal d, opposite, which is 4.35 divided by d, the hypotenuse, then I would say that d equal what? Equal 4.35 over sine what? Sine 6 multiplied by the force, which is 13,900. And by using calculator, how much is the answer? So 1388890 multiplied by 4.35 equal divided by sine 6. And by using calculator, it will be 578,000 joule, 578 kilojoule. Okay. Shukran ya Noor. Yes, we can write it in this way: 5.78 times 10 to the power of what? Of 5. Yes, you can write it in this way also. So we need to do time equal distance. No, not necessarily in this question, because they ask about the work. Aha, bravo. We need time in this question. Yes, because this power find the force, and this force we substitute here, not necessarily to find the time in this question. No, not necessarily. You mean the previous part, the next part? Okay, the next part. Huh? No. Now what they say, show that the useful work of the block is about how much? 90 kilojoule. What do we mean by what? Yes, what do we mean by this 90 kilojoule? Yes, the useful output. And the useful output, they put it up. And when they put it up here, what form of energy does it have? This is the useful. What form of energy it has? Gravitational potential energy. So the work output is the gravitational potential energy, which is mgh. So the mass, which is how much? How much is the mass? They give it to us. The mass is 2.1 times 10 to the power of 3, 2,100. 2,100 times 9.81 times the height, which is 4.35. This is the actual work done. So 2,100 multiplied by 9.81 multiplied by 4.35, and the answer will be, okay, 89614, which is equal approximately how much? 89,600 joule, which is our answer. Shukran. Now I will use all the answers before to determine the efficiency here. What is the efficiency? Efficiency equal energy or energy output, okay, over what? Energy input multiplied by how much? Multiplied by 100%. So the energy output is the work, the actual work done, which is 90 kilojoule, 89,600, divided by the energy in, which is the actual work done by the team, okay, which is this value, okay. So 5.78 times 10 to the power of 5.78 times 10 to the power of 5, and by using times 100%, and by doing that, the efficiency will be 15.5%. That means it's not efficient. A lot of energy dissipated into heat. Yes. So this value divided by 578,000, which is, yes, 15.5%. أستاذ كثير سريع، كثير سهل الامتحان، كثير في ideas. في ناس فكروا بالتايم، في ناس فكروا بالساين. Don't get confused. Focus and let's see how we are going to answer. Again يا شباب, what do we have here? We have it move at constant speed, steady speed, power equal force times velocity. We find the force to give it to us. Determine the work. Now we know that work equal force, the force that they give it to us. It's parallel to the inclined plane multiplied by the distance. So we have to find the distance, okay, by the for the sine 6 degrees. Okay, then we move on to this. Okay, Shahid, how do we know which value is the input of energy and which is one? Usually, خليني أغششك شغلة. Let me give you something that you are going to use it to cheat. The efficiency is less than 100%. So that means the output is less than the input. The output is what actually happened eventually. Okay, what's the object has an energy, maybe gravitational, maybe kinetic, depends on the question. Okay, and the input is how much work done to do that. Okay, how much we burn fuel, how much we do of work force times distance, how much, it depends on the question. Okay, how much the power of the engine, how much electricity it uses, how much fuel it burns, as I said now. So it depends on the question and the given here. So because I have two works here, two energies, I divide the smaller one or on what? On the larger one. طب أستاذ ليش ما عملنا واحد كاتب لي هلا أستاذ ليش ما حسبنا الباور الأولانية باور input على باور output. No problem, you can use the speed and the distance to measure the time. بس ليش تغلب حالك? Why you do 3 steps to get the answer in 1 step? Is it clear? شهد حمزة عبد الفتاح مبيضين clear أكيد. You are welcome. تمام شكرا عبد الفتاح شكرا شيخ. The last question. لهلا ما حليناش ولا سؤال عن المومنت. It seems that this question about moment. It is about moment. Question 19. What they said. A large parasol has been set up with what? A windy day. On a windy day. The center of gravity of the parasol is vertically above the center of the base. The center of the gravity is exactly above the center of the base. The bottom of the parasol starts to lift from the ground as shown. Okay, the weight of it is 110 Newton. So the force on the wind is 14 Newton. As you can see, it's away from the point here, as it seems that it's the pivot, okay, of how much? 14 Newton. This is the direction of the force. It makes a moment anti-clockwise, okay, above this pivot, the point of contact with the ground, okay. And as they say that the weight exactly in the middle, so approximately half the distance of 0.44 of the base, 0.22 the distance, and this force of the weight cause a moment what? Clockwise. Okay. Tamam. What they ask? Explain why the parcel will topple. You need to, okay, why it topple? Because the moment by the wind is greater than the moment by the weight. That's why. Let's do this calculation. So the moment by the wind equal force of the wind multiplied by the distance from the point of rotation, okay? Not necessarily the moment clockwise equal moment anti-clockwise, Hamza. So let's see this. The force, which is 14, multiplied by 1.8. And how much is the answer by using calculator? This is the first step. Yes, أعطوني الجواب. 14 times 1.8, which is 25.2 Newton dot meter. Second step, I need to find the moment of the weight. This is wind, capital, okay, and this moment of the weight, which is equal weight multiplied by its distance, which is how much the weight of it, 110 multiplied by 0.44 divided by 2, which is 0.22. So 110 multiplied by 0.22, which is 24.2 Newton dot meter. This one acts anti-clockwise. This one acts clockwise. So what we are going to say, since the moment of the wind anti-clockwise is greater than the moment of the weight clockwise, so it will topple over. It will topple. Why? I divide by 2. Okay, look here. The whole base, the width of the base is 0.44, and approximately they said that the center of the gravity, the weight exactly at the middle. They said exactly, okay, above the middle, above the center of the base. So I will say that approximately the weight doesn't shift that much to the left, so it will be approximately 0.44 divided by 2. And whenever it shifts more, the distance will be less, and its moment, it will be less. So this is actually the maximum moment that the weight can do, okay, about this pivot, which is the point of rotation here at the edge, okay? I will not talk about forces and unbalanced forces. I'm talking about moment and unbalanced moment, okay? The moment is not balance here, okay? Not forces and, okay, because I'm talking about stability here. Moment clockwise and moment anti-clockwise, they are not equal. Yes, shukran for your question. Shukran. Is it clear, Shahad? Is it clear, Hamza? Okay, Noor. Tamam? Okay, yes. Now write this down, take a screenshot, write the answer. No problem, no problem. You can ask whatever you want, no problem. Okay, let's move on. Part B, what they said. To prevent the parasol from toppling, a rope was attached to the parasol at an angle of at 1.5 meter, okay, away from the ground, okay, the height 1.5, okay. The rope makes an angle to the vertical of 44 degrees, okay. The horizontal force from the wind is now how much? 25 is bigger. 25 acts at an angle horizontally, so it's 1.8 meter far, 25 meter. Determined by taking the moment about the center of the base here, the center of the base, okay. The vertical force that the base must exerts on the ground. How much is the vertical force upward? Okay, the base must exert on the ground. They ask about this force, okay, R. Assume that the force at which the ground exerted on the base acts through the midpoint on the base. That means doesn't make any moment, okay? 5 marks. What do we have? This is the object. This is the pivot here, okay? Can you explain the question like what they ask? They ask about the normal contact. What are the forces act here? I'm trying to explain it. Let me draw it again, okay? What are the forces act here? These are the forces act here. We have a force of the wind acts from here, which is 25 Newton. It's 1.8 meter away from the pivot. Okay, this is the whole length. Okay, we have the weight acts downward. Okay, and this weight is 110 Newton. They ask about the normal reaction R. Okay, upwards R. And there's a tension by the rope, and this tension by the rope, it acts, okay, 1.5 meter height, and it acts with an angle of how much? 44 degrees to the horizontal, to the vertical, 44. This is the tension, okay, and its height from here to here is how much? 1.5 meter. The height onto the ground, it's 1.5. Now, what are the formulas that we have it in this question? Hi, the question, all the forces are here. Okay, what do we have? We have two formulas as usual. We have moment clockwise equal moment anti-clockwise, number one. Number two, forces up equal forces where down. Now, they ask about the force of what? Of the normal contact from the ground. Okay, what they ask? Look here. Determine by taking the moment about the center of the base, the vertical force that the base exerts on the ground, the normal reaction upwards. That's what they ask for. And that's the last question here. Now, step by step. This force, the tension, has two components. One vertically down and one to the right. The one which is vertically down, okay, TV, okay, does not make a moment. The one which is TH horizontal causes a moment, okay, because the 1.5 meter away from where? Away from the pivot, okay, it acts in this direction. So that means if I'm talking about moment only, I have two forces that makes a moment. What are they? They are the force of the wind, 25 Newton, okay, and the T and the horizontal component of what? Okay, of what? Of the tension on the rope, okay? T horizontally. Now, T horizontally and the wind, both of them, they makes a moment about the pivot, the center of the base, and they have to be equal. So this one makes a moment clockwise, and the other one makes a moment what? Anti-clockwise. They have to be equal to find the value of T. Now, this is the first step. Second step, what are the forces act vertically? I have three forces act vertically. What are they? The normal reaction up that they ask about it. The weight acts down, that's 110, plus what? Plus the vertical what? Tension of the rope, okay, T vertically. They ask about what? R. So that means first step, I have to find what? T from the moment clockwise and the moment anti-clockwise about the pivot, which is the base here, okay? So first step, خلينا نبلش. Moment clockwise equal moment anti-clockwise, okay? I draw it like this. I draw the forces of moment horizontally. I draw the forces vertically that I need to find out because I need R. Okay, so the moment clockwise is the T horizontally, which means T sine or cosine the angle here, because it's T in this direction, which is far from the angle. What I would say T sine or T cosine, because it's far from 44 degrees. Yes, Amir, shukran. It's T sine. Excellent, excellent. T sine 44 multiplied by the distance, which is 1.5, force times distance. Okay, equal what? The moment anti-clockwise, which is force 25, multiplied by the distance, which is 1.8. In this situation, how much is T? Yalla, atini ya. Give me the answer. Again, ya shabab, when there's, let me explain it here. Let me explain it here. Okay, when I have a force like this is the tension, and this is the angle, 44 degrees. I need to make two components, one horizontally and one vertically. The one vertically, I will write cosine because this angle close to it. So I will write T cosine 44. The one horizontally, I'll write T sine what? 44. Okay? You have to know this. ماشي؟ طيب نرجع هلا لها سؤالنا. So that means T equal how much يا رحال طلع الانسر؟ شكرا يا حمزة، طلع 43.2 نيوتن. شكرا يا نور، شكرا يا أمير، برافو. Okay, now that's what the first step, moment clockwise equal moment anti-clockwise. Second step, now we know that resultant force equals 0. So that means forces up equal what? Forces were down. The forces is up is only the normal reaction, okay? Equal the forces down, which is the weight, plus what? The tension vertically. And the tension vertically, as I wrote here, is what? Sine or cosine? It's cosine. So exactly. So R equal the weight, which is 110, plus the value of the tension, which is 43.2. What? Cosine 44. That means our answer, it will be how much? 141 Newton. So I can write it 140 Newton. This is the normal reaction force that acts from the ground on it upwards. Sound.